Welcome to This Explainer. Today, we're taking a deep, microscopic dive straight into your skin. We're going to uncover the raw, actual science behind skincare's absolute most famous ingredient, retinol. You hear about it constantly, right? People literally swear by it. But we're going to bypass all that glossy beauty marketing today and look at the real underlying biology. We want to see exactly what happens when this highly celebrated compound hits your cells at a molecular level. Let's get into it.
Why is retinol called one of the most powerful ingredients in skincare? It's a great question, isn't it? You've probably heard it does a little bit of everything, improving texture, smoothing out fine lines, brightening, even clearing up acne. But what if I told you this talked about ingredient isn't actually magic? Is it magic? No, it's just beautiful, complex chemistry. Let's completely break down this illusion of a miracle cure and look at how a molecule derived from vitamin A actually influences your skin cells. Okay, let's dive into this. To understand the so-called magic, we have to start with the molecule itself. Retinol is a form of vitamin A, and it belongs to a group of chemical compounds called retinoids. But here's the secret. Retinol on its own, it's not actually the active form. It's what we call a precursor molecule, and it is highly lipophilic, which is really just a fancy way of saying it's fat-loving. Picture this tiny molecule expertly navigating the oily, lipid-rich environment of your skin. It absolutely loves fats, which is crucial for its journey. But remember, right now, it's still just a precursor, waiting to be activated. Because it's just a precursor, your skin literally has to convert the molecule before it can do anything biologically active. And this happens in a very specific rapid-fire sequence. It goes from retinol to retinal to retinoic acid. Retinol, retinal, retinoic acid. It's this final state, retinoic acid, that actually flips the biological switch. This sequence is everything. Without this chemical conversion, the whole process just stops dead in its tracks.
So how does it actually get down there? Well, when you apply a retinol product, the molecule first has to travel through the outer layers of the skin, starting with the stratum corneum. Think of this layer like a tough brick wall. It's made of dead, flattened skin cells held together by a thick mortar of lipids. And because retinol is fat-loving, it uses that lipid mortar as a pathway. It literally slips right through this protective outer armor to reach the living, breathing cells waiting just below the surface.
All right, so it's made it past the barrier. What happens when the active molecule reaches the living skin cells? This is where your body's enzymes get to work, carrying out that conversion process we just talked about into retinol and eventually retinoic acid. Let's go even deeper into the cellular level to see where the real chemical transformations actually happen. Once we finally have retinoic acid, it seeks out something very, very specific, RARs, or retinoic acid receptors. Picture these as specific little docking stations located right inside the nucleus of your cells. The retinoic acid binds directly to them. Now this carries some heavy scientific weight because the concentration of the product you use and the rate at which your skin converts it directly impact how these receptors react. It's exactly why different retinoid products don't all give you the same effects, or the same level of irritation for that matter. It all comes down to how effectively that retinoic acid is locking into these docking stations. And this brilliantly illustrates what happens next. That binding acts like a literal molecular switch. When activated, these receptors actually change how certain genes are expressed. The retinoid signal reaches the cell, locks into the receptors, and quite literally changes the cellular instructions. This absolutely proves that retinol isn't just some basic moisturizer sitting harmlessly on the surface of your skin making it feel soft. No way. It is an active biological agent changing the way your skin cells are instructed to behave from the inside out.
Through this intense biochemical signaling, we see three major results beneath the surface. First, it influences cell differentiation, giving cells very specific jobs to do. Second, it influences proliferation, pushing the creation of fresh, new cells. And third, it influences tissue maintenance. Basically, the retinoids are commanding your skin cells to renew themselves, to organize better, and to maintain a much healthier tissue structure. It's fundamentally rewiring the biological behavior of your skin at a microscopic level.
Now let's pivot to one of the most famous anti-aging claims out there. What happens to collagen? Collagen is that crucial structural protein that gives your skin its strength, its support, its bounce. It's what keeps everything looking firm. But, as we all know, it definitely doesn't last forever. As we get older and as we face everyday UV radiation from the sun, our collagen naturally breaks down. The skin's internal supporting structures start to weaken. But research shows that retinoids actually influence the biological pathways that produce new collagen. They help remodel the extracellular matrix, which is essentially providing fresh structural scaffolding to counteract that environmental damage. The result?
a noticeable improvement in fine lines and skin texture. But keep in mind, this remodeling happens gradually over time. You are influencing deep biological processes here, not just swiping on a temporary filter.
Beyond aging, retinoids are also heavily used in acne management. So why can retinol help with acne? I mean, clearing breakouts and building collagen seem like two completely different jobs, right? But believe it or not, it all comes back to that exact same cellular signaling we talked about earlier.
So the crucial point is how it affects cell turnover. Retinol normalizes cell turnover and follicular keratinization, which is really just a fancy scientific way of describing the natural process of your skin cells shedding and hardening. Think about it, your pores contain hair follicles and sebaceous glands. By ensuring those dead skin cells shed properly instead of sticking together, retinol stops those stubborn plugs from forming in your pores in the first place.
Okay, so we've talked about all these incredible benefits. Collagen production, clearing out pores, literally changing cellular instructions. So why does retinol cause irritation? Why is it that when people first start using it, their skin almost always looks and feels a whole lot worse before it looks better?
It's because you are quite literally shocking the system. Your skin needs time to adapt to these brand new cellular instructions. Because you're actively altering deep cellular processes, you get what we call adaptation symptoms. We're talking dryness, redness, flaking, and even a burning or stinging sensation. It sounds intense, but it's just a natural biological reaction to a very, very potent cellular signal.
Because of these adaptation symptoms, beginners are always advised to introduce retinoid products gradually. Seriously, here is a pro tip to remember. Using more does not mean better results. I'm going to say that again because it's absolutely crucial. Using more does not mean better results. Your skin barrier matters deeply. If you rush the process and just slather on too much too quickly, you aren't going to speed up those anti-aging or anti-acne results. You are simply going to increase irritation and severely damage that protective outer barrier we talked about earlier. And that brings us to another critical caveat of retinoid usage. What about the sun? We all know UV radiation is a massive factor in premature skin aging and collagen breakdown, right?
You absolutely have to look at this as a dual strategy. Retinoids are a long-term skincare strategy used to rebuild and remodel the skin from the inside out. But sunscreen is incredibly important protection against the very UV damage that causes the aging in the first place. While retinoids rebuild, sunscreen protects. They have to work together as a team. And of course, if you are using retinoids, you absolutely must follow the product instructions carefully or seek professional advice, especially if you have sensitive skin.
Let's move to and see how this builds together into one complete picture. Let's pull the whole shebang together. Step 1, retinol enters the skin. Step 2, it converts to retinal. Step 3, it becomes active retinoic acid. Step 4, it binds directly to the cellular receptors. And step 5, that cellular signaling fundamentally changes gene expression. It's one incredible interconnected biological pathway that leads to more collagen, stronger structures, and clearer pores over time.
When you really look at the science, there is no single molecule that can magically stop aging overnight. But there is some truly profound science happening just beneath the surface of your skin. So I'll leave you with this to think about. Is retinol really a miracle ingredient, or is it simply amazing chemistry?